Lesson 26, transformations. Today we want to explore three different transformations of triangles. And just the definition of transformation is a movement on a position or form of a geometric figure. So these are also known as isometries or congruence transformations because they're not changing the size or shape of the triangle, we're just moving them to a different position. And so three of the main ones we're going to be exploring today are reflection, which means you flip it over a line, such as this. We have a rotation, which means we are turning at 90-degree angles each time. And then translation, which means we're sliding it, whether it's sliding it up, sliding it down to the left or to the right. And then other transformations we'll look at are dilation. So on this one, this figure right here, this is a smaller picture. When you dilate it, it makes it bigger. And so it just blows up the picture. Everything else would be still proportional. And then we have contraction, where the figure grows smaller. The similarity transformation. So the figures are similar and sides are proportional. So when you are standing close to something and you take a step back, it's still going to always be the same shape and same size. The only difference is it looks smaller because you're moving further and further away from it. So let's take a look at some of these terms here. We want to write the meaning of each transformation by selecting a word from this list. So translation. Translation means you're sliding it from side to side or up and down. Rotation, think of turning. Reflection, that's a flip. Think of looking in a mirror. And then dilation, that's an enlargement. So you can always refer to this slide when you want to review the terminology for this lesson. So now let's look at example 1. Describe the transformation that moved triangle ABC to the location of triangle ABC. We're going to have to use all three transformations here. The first one we're going to use is we are going to flip it, which is also our reflection. So we'll say we reflect it, and we're going to reflect it over line AC. Okay, so we're going to reflect that over here. So if we do that, this is where our new triangle will be. This is our B, that's C still. So our second step, our second transformation, we need to get this A to be all the way down where this A is going to be. So we're going to have to rotate that. And so if we rotate it, we rotate at 90 degrees. I can rotate this A so it's here. So if I do that, this is now A. And that means B is going to be down here. This is where B is located. Again, we need A to be on the bottom. So if we rotate it another 90 degrees and then another 90 degrees, we'll get to where it needs to be. So it's got to rotate 270 total degrees clockwise. Or we could say around angle C. And then our third step I'm just going to erase what I have here to put our triangle where we want that to be. So after all of our rotations, this would be our A. This would be our B. So now if we have to get this C to be next to this C, so it's going to go over 1, 2, 3, 4, 5, 6, 7, 8. So we'll say translate 8 to the right. And then we have to go up 1. And there would be our transformation of triangle ABC to triangle A superscript 3, B superscript 3, C superscript 3. Example 2, rectangle ABCD is 2 centimeters by 1 centimeter. Rectangle, or the image of that triangle, is 4 centimeters by 2 centimeters. What is the scale factor of the dilation? So if we think of this, this part is 2, this part is 1, this is 4, and this is 2. So 1 is to 2 as 2 is to 4. How do you go from this 1 to this 2? You multiply it by 2, and then get from this 2 to this 4, you multiply it by this 2. So what is the scale factor of the dilation? Scale factor for that one is 2. It's times 2 each time. The perimeter of the image is what multiple of the perimeter of the rectangle ABCD. So if we find the perimeter of the smaller rectangle, we have 2 plus 1 is 3, plus 2 plus 1 is another 3, so that's 6. So this has a perimeter of 6. This one has 4. 6 plus 6 is 12. So this is 2 times size. And then the area of the image is what multiple of the area of ABCD. Well, the area of the smaller rectangle is 1 times 2, which gives you your 2, and the area of the bigger rectangle would be 2 times 4, which is 8. To get from 2 to 8 is 4 times the size. And the last problem, rectangle PQRS is dilated with a scale factor of 3, forming the rectangle PQRS. Sketch the rectangle PQRS and label its length and width. The perimeter of the dilated image is how many times the perimeter of the rectangle PQRS. And then the area of the image is how many times the area of the rectangle. So we'll just use the rectangle that we have here. We'll say this is the dilated rectangle. And it says we need to label its length and its width. So if it's got a scale factor of 3, I would just, let's label this one as S, this is P, this is Q, and this is R. So if this top part is 6, multiplied by 3, that would be 18. This side here, PQ, 4 times 3 would give you 12, so that means this side is 12. Now let's find the perimeter of the dilated image. Is how many? So here the perimeter, 6 plus 6 is, or we have 10, 12. There's a 10 plus 10, so this has a perimeter of 20. This is going to have a perimeter of 18 plus 12 is 30, plus another 30. This has perimeter of 60. So it is 3 times the dilated or the dilated image is 3 times the perimeter of rectangle PQRS. Now the area, 6 times 4 is 24, and then 18 times 12. 18 times 12 would give you 216. So now if I take 216 divided by 24, I get an answer of 9. So 216 divided by 24 gives me 9. So the area of the image is how many times the area of the rectangle? It's 9 times bigger. So that is our lesson on transformation.